Hello, and welcome to Knowledge Graph of Drugs, Data for Swiss Healthcare System. We have our speaker today is Christian Franke, and I'll go ahead and turn it over to you.
Yeah, thank you very much. So my name is Christian, I'm from Switzerland, and the world of graphs is quite new to me. Just 11 months ago, I started with Neo4j. That's why I'm still a graph baby. Nevertheless, I have 15 years of experience with SQL and BI tools. But today, as a graph beginner, I'm glad to share my experience and the challenges of my first year in the graph world. So why did I start with graphs? On the one hand, I work for Swiss TRG, where we calculate the so-called diagnosis-related groups. For inpatient hospital treatment, there could be an extra charge for expensive drugs on top of the lump sum. For us, it's very challenging to recognize all the expensive drugs because the information is spread in the internet and on multiple databases. On the other hand, I studied medical informatics in the Bern University of Applied Science. And I put the two worlds together for my bachelor thesis, and I wanted to combine Neo4j with the challenges of finding information. So I created a knowledge base for our drugs data. During this process, I made mistakes, but I think I found nice solutions. And I hope that as a beginner, you can learn some basic fundamental ideas. And even as graph expert, you get another point of view. So after some general information, I will focus on 6 examples to get a look to data modeling and visualization. Okay, just a quick background info. I use public available drugs data of Swiss and European medical agencies and also from other governmental health organizations. I prepared the data with R, created some CSV files, and I uploaded them to Neo4j. This is a very simplified, sorry. Now you should see my screen. So this is a very simplified data model of my drugs data. Besides the medicaments, we have the package information with a price, for example, for 10 or for 20 pills. Besides that, we have the substance nodes on labels. They are grouped by ATC codes from World Health Organization. The ATC codes are very common here in Europe. So let's get some general topics before you first start your graph. In my opinion, Graph Academy is very good for starting because the courses are very well structured. You have some hands-on experience, explanations, and videos. And in my opinion, it's better than just looking YouTube videos. YouTube is fine, but Graph Academy is more structured. And for me, that was quite good. All you need to know, all you need for developing your first graph is Neo4j Desktop. If you want to share your graph, you can use AuraDB. I didn't reach the limit of 200,000 nodes and 400,000 relations. So Neo4j is just fine for starting. If you dive into the world of graph data, for your first graph, do a reliable project management. Because if you do your requirements engineering, implementation, testing, refactoring, and the documentation, if you're doing this seriously, it helps to keep an overview besides all the new technology stuff. For me, it also was important to start with the data that I know, because it was easy for testing, it gave me confidence, and it was a quick success. And of course, take care, you probably have to flip your mind. You have to flip the way you think about data. Okay, so now let's dive into the examples. Imagine you have relational databases, a database with 3 tables. If we transform them to the graph world, we have 3 labels instead of the tables. That's fine and work. And for me, it was quite impressive to see my data in a shining galaxy like this, and not instead of a boring table. That was quite amazing and motivating. Nevertheless, if you transform all your tables to labels, you probably have problems with graph algorithms. In this case, the shortest path is calculated via the unit, milligram. That's technically correct, but absolutely useless because nearly every substance has a unit milligram. So it has no, it's not necessary to know this. If we better delete our, I call it common data, and we store these data in the main label, in this case, a substance, then we can use graph algorithms that are useful. In this case, the same shorted path gives me the information that I can use both of these medicaments for the treatment against multiple myeloma. And that's quite interesting. So keep in mind, if you have dimension tables or hierarchy tables or stuff like that, probably it's better that you store these data as attributes and not as labels. Okay, next example. In our ER diagram, we have these tables and we create labels. That's fine and works. These tables are connected end to end with an extra table with all the foreign keys. If we transform this to the graph world, we just create relationships. That's straightforward and really easy and gives you lots of possibilities, like, for example, analyzing clusters. Here we have clusters, and I had similar questions to analyze my data with pure SQL, and I did not found a nice solution. But with graphs and with this relationship, it's quite easy. Perhaps you can do correlation matrices and count these nodes and connections, but in my opinion, it's easier to analyze clusters instead of matrix numbers. Okay, so let's go on. If you have untidy data like this, in a data warehouse or BI tool, in general, you create 2 rows instead of 1 with an array. Then if you take these rows and convert them with a merge and set statement into your graph world, you get 3 rows instead of 4. Because depending if your node exists, this merge and set acts like an insert statement or like an update statement. So there you have to care, but you don't have to care at the same time if you just use your array data. You don't need concepts like first, second, or third normal form. You just store your array data directly in the nodes. And if you need the data, you can unwind, use the unwind method, take the data and even calculate with that. It's quite straightforward, and it's normal, in my opinion, to work with arrays. Okay, now we're going to my favorite example. Here we have a medicament in purple, and this connection and this information comes from one data source. The package information, what you can see here, comes from another data source. And the package information has another ATC code than my medicament, but it's the same medicament. Now I know that the package information is more up to date, and I don't want to connect the package directly with the ATC code. I want the medicament connected to the ATC code. And that's quite easy with a very basic cipher statement. I just select or I just match all the nodes that I need. I check if here the connection exists or not. In this case, it does not exist. And I create I call it indirect relationship. With this approach, you enrich your data from different multiple data sources. And keep in mind, we did not create here a relationship between labels. We only created a relationship between nodes. And this is quite cool. In a data warehouse, you probably would create a data cleaning process or end-to-end tables or whatever. And here it's quite easy to create the new relationships, and the client can use these relationships. Okay, the next example is quite strange in my opinion, and I have no explanation. Probably the Neo4j stuff has an explanation, but I found a nice workaround. Now we dive into the visual analysis. Here we are in Bloom. We have two substances. We have two nodes in yellow. Now, if we go further and say one of our substance is expensive, we give it an expensive drug list label. This label now is blue in general, because we also have this third node, what is directly an expensive drug, but not yet a substance. So here we can see the drugs, but unfortunately we can't see, we still see that one of the drugs is yellow. If we go further and change or add the substance label to our drugs nodes, then all of our labels, all of our nodes appear now in yellow, like the substance, even if we only search in Bloom for our expensive drugs labels. The nodes appear, but they don't appear in blue and yellow, so that we can't distinguish anymore for graphical analysis or visual analysis. For a workaround, you easily can save this information, if it's expensive or not, as attribute in your substance node. Here I created a flag, and with the rule-based formatting in Neo4j Bloom, we can say, okay, if this flag contains a word, or it starts with a word, or whatever, then it appears in blue or in purple or another color, or you can even create ranges. With this, you have now your distinction between your different nodes. I did it, for example, with a range of prices, what you can see here, all the dark nodes that are really high-priced drugs, and all the low one are cheap drugs. This generates a focus for your visual analysis. Okay, last but not least, I have one thing also for Neo4j Bloom. By the way, I really recommend this training series. There you get nearly everything you need to know about Bloom or Explore. So if you're doing your Explore and Bloom saved cipher queries, for example, and you create perspectives, and you're analyzing this and you're sharing this data, probably you want to use deep links to connect to your data from other applications. I did so, and unfortunately, I created my first perspective, which I named with a version 1.0. After updating my data model, I updated my perspective, and then the perspective was version 1.1. So that's why the deep link doesn't work anymore. I had to update my deep links. And if you use deep links in multiple applications, then you have to update your applications. And of course, you have to deploy all the applications. That's why I recommend perspectives without version names. Okay, in fact, that was it. These were the 6 examples. Here you get the summary. If you have further questions, just send them in the chat or write a message in LinkedIn. All the slides and the examples you will find on my GitHub repo and additional stuff on the website. So thanks a lot and happy graphing.